So in addition to multiplication of matrices, I can also decide to explain little on scalar multiplication. If you have a matrix A to be equals to 2, 1, 4, 1, 5, 3, and then matrix B is given as 4, 1, 3, 2, 1, 6. Can you multiply this and this together? It's not possible because I already said whatever you have on this row and this column, you must have the same digit on them. You have 3 digits here, you have 2 digits here, so you can't multiply them together. What about BA? BA is possible. BA I have, okay, BA2 is not possible. B, I have this on the first row and the column I also have one, so it's not possible. So what if I add 1, 2, 1 to this? And then you can go ahead and multiply this together. This will multiply this, so this is the product of this A and B exists in this case. So what if you want to find, let's say the question now say find 2A minus 3B. This 2A is a scalar multiplication of that matrix. So if you want to multiply something like this, A times B does not mean so you just go ahead and do 2 times 4. It's not allowed. 1 times 1, 4 times 4, no, 4 times 3. That's not allowed, okay? So, but in this case, whereby you have 2A, 2A implies this is 2, and I have my A as 214, 153, then minus 3, and then this B is what? 413, 216, 121. You can only have a constant product if, sorry, you only have a scalar multiplication of matrix if and only if a constant is actually multiplying any matrix. Okay, take note. If you have any constant, whether 3, whether 2, whether half, multiplying any matrix, then we call that kind of product, we call it scalar multiplication of matrices. So in this case, this is just direct product. 2 times 2, 4, directly. 2 times 1, 2. 2 times 4 is what? 8. 2 times 1 here is what? Is 2. 2 times 5 is what? 10. And 2 times 3 is what? 6. Minus, this minus sign is there. So this constant will multiply each and every digit you have in that matrix. 12, 3 times 1 is 3. 3 times 3 is 9. 6, 3, 18, 3, 6, 3. So you can now go ahead and subtract. Okay, 4 minus 12, you know what that will give you. But can you actually subtract this together? That means this does not exist. Yes, do you know why? If this subtract this and this subtract this and this subtract this, 2 must subtract 10, 10 minus 3, 6 minus 18. So what will you have for the last one? So what I get used to subtract this also is not allowed. So that means under addition, take note of this rule. Under addition and subtraction, you can only add a matrix with the same dimension, and you can only subtract a matrix with the same dimension, because the dimension of this matrix is just 2 by 3. This one is what? 3 by 3. So you can't add 2 by 3 matrix with 3 by 3 matrix. They must have the same dimension. You see, the same rules goes for subtraction also. So this is what I'm trying to say. So you have to be very careful for addition and subtraction. If you have any matrix, if you have 2, 1, 5, 3, 1, 1, what is the dimension of this matrix? If I may ask you, okay, what's the dimension of this matrix? The dimension of this matrix means count the number of digits you have in each column, or possibly just take one column and then count the number of digits. That's 1 to 3. That's 3 by, how many digits do you have horizontally? 2. So this is 3 by 2. The dimension of this matrix is 3 by 2. What of 2, 1, 3, 1, 6, 4? This is what? 2 by 3. So you can't add these two matrices together. Under addition and subtraction, the rule says you can only add a matrix with the same dimension. Like if you have 2 by 2, 2 by 2, this 2 by 2 matrix, okay, 2 by 2, 2 by 2. So you can go ahead and add them. The addition will exist. But if they do not have the same dimension, then it does not exist. Okay, so that's how it works.